Hi, I'm Sukanya, and I'm going to talk about my research proposal. So, I'm actually doing it on conversational dialogue systems, and my research question is how can dynamic memory network plus method can improve the performance of an end-to-end non-task oriented dialogue system towards achieving bilingual evaluation study score of perfection equivalent to 1. So this bilingual evaluation under study is something that is used to measure like how the conversational data input and the output is correlated. So that is one of the most used method to evaluate any dialogue system. Is it whether it's a task oriented system or a non-task oriented system? They mostly use this because uh, this belief has a lot of correlation with the human evaluation. And why am I doing it on this topic is that the main thing is that people actually do it on task-oriented systems like personal assistants, Alexa, such as Alexa and your phone assistants that you have. So most of the things are in task-oriented systems is that you have a specific rule set defined, and you will be evaluating and get the most probable answer for that question given. It is mostly mechanical and the rules will be defined and it's easy to do and implement, even though on a larger data set it sometimes even become tougher. But achieving this non-task oriented system is highly typical, and there is a lot of research going on from different projects and in the different scientific societies on to achieve a model which performs like an ELISA model. If you know ELISA is something uh, which almost passed Turing test back in the 90s. So that's a system which actually confuses the user whether it's really a machine talking or if it's um, a person. I mean, whether you cannot actually differentiate whether it's a machine or a person. So that kind of you know field is not given by any of the non-task oriented system or any dialogue system in the present day. So when you see the dialogue system uh, model, so the flow goes like this. So it starts, the person speaks something, and then we have automatic speech recognition, which recognizes and then converts to text. And then we have natural language understanding. So whether it's English or any other language, the machine has to understand the language and then convert, understand the semantics, and then use dialogue management to again pass the semantics to for natural language generation, like what is the context and what are they asking me for. So I can understand through natural language and then produce a management and then uh, produce an output and pass it to the text to speech synthesis and then produce the audio output again. But in this project, we're not going to do the automatic speech recognition and text to speech synthesis, but we will be doing the natural language understanding, dialogue management, and the natural language generation. We'll be mostly focusing on the data analysis and the natural language processing of this project. So this is actually the dialogue system model. But what is the main difference between the end-to-end dialogue system and dialogue system is that end-to-end dialogue system does not need any feature engineering, and they do not actually have to stick to this modular engineering. So we have different modules here, and all these modules will have a high um, importance, and these have to be constructed manually. And this does not happen in end-to-end systems. You just give the input and the output should automatically get produced without having all these independent modules that requires a lot of handcrafting. So, and the novelty in this project is that the number of end-to-end dialogue systems on non-task oriented systems are just one or two, and then that means it's actually negligible compared to the task-oriented dialogue systems that we have today. Um, so that's one of the important thing that we have to consider. And the novelty is basically the dynamic memory network plus, which is an interesting methodology that I'm going to explain here. This has been never applied to the data to process and to produce natural language generation. We can actually implement this, which has never been implemented on non-task oriented system. So I'll be explaining more about it in the further slides. And the motivation behind this is that the conversational AI, so nowadays the artificial intelligence is a hot topic right now in the market, and I'm going to do it on conversational AI. The machine has to understand, and machine has to respond in a way that it is almost equivalent to the human intelligence level. And there are broad ranges of applications for this, and it can actually be like a friend or if you implement something, some machine, some robot or anything, it the basic thing that it needs to do is to converse like a human, and that's what we are trying to do it here. And the research has actually shifted towards end-to-end dialogue systems because the computational capabilities of the system of a computer system have increased, and they can actually hold on to a lot of data. And with lot of data, we can actually produce a model which performs, which doesn't have to be taking a modular approach of building each module like natural language understanding, all these modules. So what happens when we in the traditional dialogue system is that when we when there are some errors happening in natural language understanding module, then these errors will actually propagate and affect the dialogue management, the next module that is present. So that will not actually happen in an end-to-end system. So the number of errors are going to decrease. That's one of the important feature. And yeah, as I previously told, we do not have to select what features impact and have high impact on the model to give a good output. We don't have to deal with the feature engineering. We just have to deal with cleaning the data set and then applying the model, and the model will automatically do the rest of the work, which actually saves a lot of time. And it actually this non-task oriented system is actually vital because this can be integrated with any task oriented system. For example, if we have a task oriented system like a a customer care center which has the input calls coming in, and the mm, robot, the bot, the chat bot or robot has to answer back for the thing. So it has a particular task to do, and if it doesn't know how to make a normal conversation, it's going to be tough for further things. I mean, the humans will not have a very good relation with the machines to let them do their work. So, and it could be any task oriented system, like for example restaurant booking system or any other task oriented system. We can actually we need to have a non-task oriented chit chat system which can normally converse with humans. So we can actually prepare one and integrate with a task oriented system. That's if a perfect non-task oriented system is model has been created. So the methodology in this is we have collected data, which is a movie dialogue set from a very large corpus available. So we have all kinds of like millions of records in it, the dialogues, but we'll also have a bad words or hate speech or any negative comments or any racial things that we need to process, and which should be taken care of well before building the model. So we have to do data processing. So in this step, we have something like support vector mission. This is an easy algorithm to apply to classify between the bad words and the normal words. So whatever we have, whatever the sentences that are having a large number of these hate speech and etc., so we can actually classify and into two things, and then we can remove the negative speech that's happening in your data set. And then you can pass it to the glove. Glove is something called global vector. So it actually converts all the words in your sentences to vectors. So what happens is that the machine will be able to identify your words that are sentences, and the when we convert them to vectors, it becomes mathematical. It will be able to form mathematical relationship in a vector space. So when we have father and mother, the father will be given a particular number and the mother will be given a particular number. So when we have these converted to vectors, we can actually map the distance between them and form much more many more things. And after forming these vectors, we just pass them to the DMN place, dynamic memory network place, and then we evaluate the results using BLEAU as explained before. And we have to do pre-processing. I told you how the pre-processing works. And we have GLOW and the SVM for text classification. And why is it fit for, am I thinking that SVM is and GLOW are the best ones? So these are the supporting documents for them. And we have an example of DMN plus. This is a very good example that I got a frame. So assume that an article was actually given to you to memorize, and it is taken back from you within seconds. And then I ask several questions to you to related to that particular article. So you wouldn't be able to answer all of it in just a glance, and you would be missing some points here and there. So why is that happening? Because your working memory is actually incapable of storing all the details, and secondly, you're given less amount of time, and you cannot go back and check what was in there in your memory. And the focus will also be on different unimportant things. You will be reading the whole thing all at a time, the article at a time. Maybe you will be focusing on some unimportant things that are not related to the question. So what happens is that the solution for this is that given the material with the along with the questions, and you're allowed to see how many glances you want and get back to the article and then flip here and there to answer the questions, that in that way you can actually produce better results. So that's what DMN plus does. So I'm going to show how it works. So we have the input module, something called input module, and the we have input fusion layer, and then we have episodic memory and output layers. So in input module, the input and vectors that are given and the questions will come, and then based on that, facts will be generated. And the detailed explanation is here, where we have these are all vectors, W1, W2, all these are vectors. So in a given sentence, and then we have the position. So everything is in an order. So we have something called GRU, that is gate or recurrent unit, which is more probable of which can actually control what elements to pass through and what are the real facts. So it is actually bidirectional. That means you can actually flip back to the place where your question started. I mean, maybe if you have any relationship with the first question to the second question, you can actually go back and see what are the facts they have generated, and then come back and use them for the present situation, which was not there in the other things. For example, we have LSTM and other recurrent neural networks, but they use memory, and they have they use working memory, and they have they need a lot of computational capability. And in this DMN plus, that's one of the big advantage that happens in in the memory itself, working memory itself, and it doesn't need much of the memory, and it manages everything with the recurrent unit, storing the important facts and not everything that goes in and out of the system. So we have something called episodic memory pass. So in this we have gate attention. Gate attention actually is connected to all these facts. It will have all the facts connected, and we have attention GRU. which will work on attention mechanism, which I mean, it selects what are the important facts. I mean, if a given question comes, then it goes to the episodic memory and see if there are any relationship with the existing questions and what is the best probable thing. And it again updates the memory after once after the output is decided and a particular fact is generated, it again updates the memory. So, and why am I taking DMN Plus is that it has been proved to work well with videos, video recognition, and image recognition, and question answering bots. And I guess, I mean, question answering bot was just a minor experiment, which was not a full scale one, which has a very few dialogues. They did not complete it fully, but I'm going to do it on non-task oriented system. I mean, it has the system should be able to engage with the user and provide relevant outputs. That's my motto. And the DMN Plus, it has extra infusion input fusion layer, which helps to derive the context properly. So when I derive facts, and also it can flip back and forth, checking for the right context. And we also have the bidirectional attention based GRU, which can reason, and I mean, which can see what's happening, and it can provide better output. And here is one more interesting example. See, we have asked about where is the apple. I mean, this is one example that I'm providing. So we have input module, and here John moved to the garden and everything. So when we ask the system where is the apple, then it goes to the episodic memory and thinks what we have spoken, what were the previous tasks, what happened previously, and then it can evaluate everything and produce the right answer where the apple is. And this is one thing that the previous project people did, and they were able to classify on image. So I have already explained on DMN plus, that's the same thing. And evaluation with BLU, as I told, it's a bilingual evaluation under study, and it proves to be highly correlated with human judgment. And this is my Gantt chart. So this is planned according like how many weeks it takes, and the explanation of this is actually given in the document as well. But I'm going to give a brief on it. See, here I have allocated more on DMN plus implementation. I think it requires a lot of coding and other things. So I have given a lot of time, more than like almost around 3 weeks of time, and also for documentation of all these things that on documentation is a lot of time. So I have given almost 3 weeks for the documentation. My aim is to complete all of the coding work and everything by week 10. And thank you for listening. And that's all. And these are my references. Thank you so much.